So we have reached the end of our content for 8th grade science, and we are starting Milestone Review. And we are going to start with standard S8P2. We're going to work through just the highlights of that standard. You're going to need something to write with and some highlighters. The first thing we're going to do is just go through some basic terms that you need to know in order to master standard S8P2 for the milestone to do your best. And the first term is energy. So energy is the ability to do work. If you don't have any energy, then you can't do any work. So energy is the ability to do work, and the units that it's measured in are joules. Then we have kinetic energy. Kinetic energy is the energy of motion. Kinetic energy is the energy of motion. And the formula for kinetic energy is 1/2 mass times velocity squared. So kinetic energy is based on the mass of the object and how fast the object is going. All right, then we have potential energy, and potential energy is a stored energy. Potential energy equals the weight of the object times the height of the object, how high it is off the ground. And remember that weight is mass times gravity's number, which at high school will be 9.8 meters per second squared, the acceleration of gravity, but for middle school we use 10. So mass is the amount of matter in an object. Mass is the amount of matter in an object. The more matter you have, the greater the mass will be. And mass's base unit is grams. I'm going to go back and add that this is joules. Speed is how fast an object is moving. Speed is a rate of the distance over the time. So speed is typically going to be in meters per second. Velocity is very similar to speed. It is just speed with a direction attached. So it would be like meters per second north, south, east, or west. Height is the measurement of something from bottom to top. Remember, it comes in up here at potential energy, how high it is off the ground. We would typically measure that in the base unit of meters, or it could be centimeters or decimeters or kilometers. Also in standard S8P2, which is all about energy, we're going to have energy transformations where we go from one thing to another that we'll look over and review together. And that's the flow of energy from one form to another. Chemical energy to mechanical energy. Mechanical energy to thermal energy. You remember those. And then we've got heat transfer. That's just going to be the flow of thermal energy. And thermal is just a fancy word for energy. Remember conduction, convection, and radiation. That's going to come up in a review. Molecular motion is just going to be the movement of molecules. Molecular is just kind of a way to say molecules, molecular and molecules. Movement is another way to say motion. And then we've got conduction, the transfer of heat with direct contact. We'll go into more detail about that. My little memory trick, conduction has a D, direct contact has a D. like you're directly touching something like a pot sitting on a stove or a steak searing on a grill. Convection is the transfer of heat by currents. So that would be like a gas or a liquid. That's going to be warm air rising and cool air sinking. And then what's that last one? Radiation, the transfer of heat through waves. And that would be the heat that we feel coming off of a fire or heat from the sun. Radiation can travel through outer space. And then the last big concept for this unit is going to be the law of conservation of matter, which that shouldn't say matter, actually. We have a typo. That should say the law of conservation of energy. Energy cannot be created or destroyed. It can only change forms. Energy cannot be created or destroyed. It can only change forms. It's the exact same thing as the law of conservation of matter. It's the same concept, but we're just thinking about it in terms of energy rather than matter. So for this next section, you're going to use the arrows to show if energy increases or decreases. Think about it in terms of these formulas right here. Kinetic energy is 1/2 mv squared, and potential energy is weight times height. And weight is, of course, dependent upon mass times acceleration of gravity. So give this next little section a try, and then unpause the video, and let's check your work. All right, so checking through these, this first section, if mass increases, kinetic energy increases. If mass decreases, kinetic energy decreases. If mass increases, potential energy increases. If mass decreases, potential energy decreases. For this next section, if velocity increases, kinetic energy increases. If velocity decreases, if you slow down, then kinetic energy is going to decrease. And then for potential energy, if height increases, potential energy is going to increase. The higher you are off the ground, the more potential energy you're going to have. If height decreases, potential energy decreases. And then in terms of speed, if we speed up, then kinetic energy is going to increase. If we slow down, kinetic energy is going to decrease. In potential energy goes up, kinetic energy goes down. If potential energy goes down, kinetic energy goes up. And I want to make note that they are inverse. If one increases, the other decreases. All right, now looking at this graph with kinetic energy and velocity, according to the graph, will kinetic energy increase or decrease as velocity increases? So as velocity increases, we see that kinetic energy is also going to increase. And then, according to the graph, what will kinetic energy do if velocity decreases? It will also decrease. Okay, flip on over. So now we have a new graph of potential energy, and we've got to look and see what is the correct title of this graph. And the correct title of this graph should be, they have energy. The correct title would be energy versus height, dependent variable versus independent variable. What is the y-axis? Okay, let's make our math teachers proud. This is our y, and this is our x. So our y-axis is energy, our x-axis is height. So what does this graph tell you? As height increases, the higher up I go, so does my energy, so does my potential energy. So let's take a moment and highlight that information. All right. Then for this next activity, our big idea that we have As potential energy increases, kinetic energy decreases. As potential energy decreases, kinetic energy increases. And that's that idea that they are inverse of one another. Okay? So next we have these pictures. We've got a roller coaster and a spring. So number one, in the picture above, the roller coaster must have the most blank and the least blank at point A. So at point A, we have the most what? Here. We're highest off the ground and we're paused. We're not going very fast. So at that point, we're going to have the most potential energy. If our potential energy is maxed out at that point, then we're going to have the least amount of kinetic energy. The roller coaster will have the most kinetic energy and the least potential energy at point B. So this is where we have the most KE, and this is where we have the most PE. So label that in your picture. Number 3, which spring has the most potential energy? When it's pulled out or when it's squished in? And that's going to be answer B. So this is the most potential energy here in this picture. And it has the most kinetic energy at point A. That's when it's moving the most. Let's draw an arrow to show movement, and that's the most kinetic energy at that point. The most kinetic energy. Alright, so on the next page we have a pendulum, and it's being swung. And it said, at what point does the pendulum bob have the most potential energy? And that is going to be when it's highest off the ground at point G and point A. So take a moment and highlight that on your picture and answer the question. At what point does the pendulum bob have the most kinetic energy? And that's going to be when it's closest to the ground at point D. Okay, does the graph represent potential energy or kinetic energy? Y. And it represents kinetic energy because D is at the highest point. See, here is D, D, and D. So this represents greatest potential energy, kinetic energy. Now for this one, which rubber band has the most potential energy? That's going to be when it's here, pulled back. This is going to be the most kinetic energy when it's released and moving. Now for this next section, you have a chart that we're going to use for energy transformations. Take a moment and complete that. We're going to highlight it. We have electrical energy, electrons. We have mechanical energy, motion. We have thermal energy, heat. We have nuclear energy stored in the nucleus of an atom. We have sound energy moved through vibrations and waves. We have chemical energy in the nucleus of atoms. We have electromagnetic energy from the electromagnetic spectrum. And then fill out this part over here. Then you're going to complete the energy transformations on the next page. Pause the video and then use my page to check your work. So to check your work, we have chemical going to mechanical for the apple to the bicycle, chemical going to light for the battery to the flashlight, electrical going to light for the cord to the lamp, chemical to mechanical, gasoline to the car, electromagnetic to chemical for the sun to the plant. The sun could also be nuclear and thermal. Electrical to thermal for the toaster. And then remember, as heat increases, kinetic energy increases and molecules move faster. As heat changes, states of matter also change. Heat moves from warmer to colder. And then here's our information on conduction. It's touching like a pot on the stove. Convection, like boiling water. And radiation is waves, like heat from a fire.